Hello and welcome to another one of my recordings. Through this recording, I'm going to cover some of the concepts covered in Chapter 12 on handling exceptions or errors in your code. And we'll also talk about manipulating text files, essentially how to read from a file and how to write to a file. As far as errors are concerned, you've seen so far programs where Java doesn't gracefully exit your code. So if you ask the user to input an integer and you input a string or a floating point number, it will essentially crash, and it won't give you an idea to recover from that error. Dividing by zero, finding the square root of negative numbers also cause programs to crash. If you try to access an array's element that doesn't exist, or if you try to read from a file that doesn't exist, you will get error messages. So this chapter essentially talks about how to handle or deal with these kinds of errors. So the first set of programs I want to open up, and we'll work together on them, is so if I go here, I have quotient. I'm going to go ahead and open up all of these files, and so essentially there's this file is called quotient.java. Notice all I'm doing is I'm asking the user to input two numbers. So if I go ahead and compile this, and this might take a while for it to compile, but so essentially what this program does, it asks for two numbers, and then it displays the first number divided by the second number. So as you might expect, if this second number is 0, we will get an error message. So the idea is that, well, how would I handle this? How would I make sure that this doesn't happen? So while this thing is compiling, I'm going to go ahead and peek through this example, where one easy way and one common way, and actually a good way to handle these errors, is to put an if statement in your program, so that we're saying if the second number 2, is not equal to 0, then perform the action. Otherwise, you provide an error message, and this is perfectly fine. And you'll find out that actually exceptions or handling exceptions, as far as CPU is concerned, is CPU and memory. It is intensive, so you want to avoid using exceptions all the time. So this is perfectly fine to check using an if statement, and then accordingly deal with the error message. So that's and then this file is still compiling, so we'll wait for that. And then one other thing that we could do is we could do this example essentially allows you to catch the error, and we will see that we use a construct called try and catch errors. So you notice what we're going to do is that we read the two numbers just like before, except here we're saying result equals quotient number 1, number 2. So it looks like we wrote a method that returns the total of the or actually divides the two numbers. Oh, this program compiled, so we'll come back and explain that. So you notice with this example, if the user puts in two numbers that are valid, say 10 and 2, quotient, again, which is a function or method that we wrote, is going to take these two numbers, and we're just essentially saying if the second number equal to 0, we're going to throw a new object from this arithmetic exception class, and then with a note or essentially a message sent to the constructor of this class. Again, we'll talk about this arithmetic exception class shortly, but that's how it works. So let's go back to this quotient.java that compiled. So if I run this program, if I put in 10 and 2, obviously I'm going to get 10 over 2, which is 5, and I'm done. If I run it again, and if I give it 10 and 0, notice it tells me that there is an exception in thread main. Notice the exception class or the error class is arithmetic exception. And this is Java's message, slash by 0, and it tells you what line it died on. So if I go here and do view line numbers, line 12 is where we tried the division essentially, and that's where we get the error. So notice there is no way of catching the error, and that's the way Java deals with that kind of error. It just throws an exception of its own, and it's not very graceful. So quotient with if is kind of nice, because if I compile this and then ran this, so notice again, if I do 10 and 0, I'm getting my own message that says divisor cannot be 0. And then again, we can always continue with the rest of the program. As you might expect, you probably could use a loop here, so that so long as number 2 is not 0, we can keep asking the user to make sure we validate and have a good number. So this other one that I was talking about, this quotient with exception, we'll get to that one exception, is that what we're saying is if number 2 is equal to 0, throw this exception. So notice when we run this program, it'll ask us for two numbers. And let's say I put in 10 and 2. Well, 10 and 2 go in here. 2 is not 0, so we won't throw the exception. And then program comes over here. It divides the two numbers. It's not going to go into the catch block because no errors occurred. And it says program execution continues. But if I give it 10 and 0, let's say, where the second number is 0, this method throws an exception and essentially tells Java that when you come back here, go to a place or the block where that particular exception is caught or to be caught. Notice the syntax here is the name of the class followed any object name. So that could be anything you like. So we just call it EX, short for exception. And here again, we're putting our own message that says you can't divide by 0. And then, of course, execution occurs. So the catch, I guess the thing to take away from this example is that once that exception is thrown, this line is never executed, which is a good thing because you don't actually want to display anything. If I compile this and run this, so again, if I put in two valid numbers, this program works exactly the way it should. So for 10 and 2, you get that, and it says execution continues because we didn't go here and we never threw an exception. But if I give it 10 and 0, you'll notice that an integer cannot be divided by 0. That was the message in my catch block. And which is again a lot more graceful, and the execution continues. The program doesn't actually die. Remember, with the previous example, the program automatically terminated, which is good. So if you have tons of other program to do, just for one error, you don't want your program to stop. Now, this example, quotient with exception loop.java, essentially creates a loop that keeps checking for valid numbers. In this case, looks like we're asking for an integer. And notice I'm grabbing in the try block, I'm grabbing the input statement. So if the input has a decimal point, or if it's a string, what happens is that the catch exception or the catch block will get executed. By the way, we'll talk about these different types of exceptions shortly. But input mismatch exception would be something like you ask the user for an integer, but a good integer or an integer is not entered. Notice the purpose of the loop is that it keeps repeating. So valid number is false, not false is true, so you enter the loop, and then we say, well, let's look at this integer. Now, if it's a valid integer, let's say I put in 12, no problem, num3 becomes 12, valid number becomes true, so when we go back, not true is false, and then we exit the loop. If I give it a wrong value, a wrong type of value, this statement does not get executed, because as soon as there is an exception, essentially the process moves to this block of code. It says, hey, enter a valid integer. It discards the extra essentially carries return at the end of the in our buffer, goes back. Valid number, remember, is still false, so not false is still true, and then we grab the next number. So notice with this example, if I put in 10 and 2, and then it's going to ask me for an integer. If I put in 90, that's no problem. And then it says find the square root because I have more program to go, but let me just run through this so you can see what happens. So 10 and 2. So here if I put in 2.8, it'll say that's not a valid integer, so it's going to ask me for another number. So if I put 3.99, still it's going to tell me to put an input or input a valid integer. And remember, if I put in A123, same thing. But if I put in 12, that will work just fine, and then the program continues. Again, when you again, I will give you all these files. So when you examine these, you can see that I have other types of exceptions that we're going to deal with. Something like a square root of a negative number, or an array bounds exception. So notice I've created the array with 5 elements. But here I'm trying to put in something in the 5th element, or element number 5, that doesn't exist. So we have this index out of bounds exception. Okay, so let's go ahead and go back to our slides. So again, those are those examples that you could also walk through. The advantage of the exception handling essentially is that your program does not terminate. You're able to continue with doing more, essentially more debugging, and or actually continue running your program. Input mismatch exception, that would be one example where I just talked about, where you put in a float for a integer data type. Now, this slide is very important because, as you remember, in Java, everything, all of our essentially classes inherit from a class called object. Throwable inherits from object. Of course, we have tons of other classes that inherit from object. We have two types of exception types. We have exception and we have error. Now, exceptions and errors are very much alike, so sometimes they cause confusion, I guess, just with the terminology. But just remember that they both mean errors. The only difference is that errors are things that we really can't handle. If there's a linkage error, or the Java virtual machine has an error, somehow we ran out of memory and we can't handle, we don't know what to do. We really can't do anything about errors in code like that. So we can't really handle these. So these are essentially called unhandled exceptions. And then the exception class has some of these exceptions, like class not found and IO exception and runtime exception. Well, class not found exception and IO exception, class not found would be something like an error that the compiler catches. So if you try to use the scanner class without having imported the scanner class, you'll get that message. So the compiler essentially checks this and tells you about it. IO exception, same thing. Sometimes if we read from files or write to files that don't exist, or folders that do not exist, then we get that kind of error. But runtime exceptions essentially are errors or exceptions that are such as arithmetic exception, which we just saw, null pointer exception, attempting to essentially look at an address or somewhere in memory that doesn't have an address or a value, so we get null and we can't do that. With arrays, if we go index out of bounds exception, and illegal argument exception. So these classes, again, there are tons of more classes. These are the type of essentially classes that Java give us. So think about this as a bunch of predefined exception classes. Well, of course, because they're classes, Java gives us capabilities to create objects from them and also to use their respective methods. So system errors are thrown by the JVM or the Java virtual machine, and these are the things that we really can't do much about. And then exceptions are things that are caused by our program, and these are the errors that we can actually catch and handle them. So all of these can be caught and handled by us. These errors cannot. Okay, so in this chapter, we're just talking about exceptions, things that we can handle. Now, runtime exception is caused by programming errors. So if you typecast something inappropriately, or if you try to access an out of bounds an array, or make a numerical error, those are all essentially referred to as runtime exceptions. Now, we have two types of exceptions: checked exceptions versus unchecked exceptions. So runtime exception and error and all of their subclasses are called their unchecked exceptions. So runtime and all these are unchecked exceptions, essentially meaning that the compiler doesn't check those for us. All other exceptions are known as checked exceptions, meaning that the compiler forces us to check and deal with those exceptions. And again, some of these checked exceptions are caught by the compiler. So if we're going to check for the existence of a file with an I/O exception, essentially we have to do that ourselves in our code. So we'll see examples of these. So unchecked exceptions, again, these reflect programming logic errors that are not recoverable. So a null pointer exception or index out of bounds exception, those are the things that we can essentially try and catch in our programs so that we won't essentially terminate or stop the program from execution. Okay, so these two are important names that we just talked about. Unchecked exceptions, this is issues with the code logic, such as divide by zero or bad numeric input. Java declares these for us, these unchecked exceptions. Again, we'll see a couple examples on these two. Checked exceptions are usually the ones that compilers deal with. So if you're missing a class, Java will actually tell you about it. So these two, as you read your book on these two exceptions, just as far as terminology is concerned, just remember that check exceptions are the exceptions that the compiler essentially deals with or can deal with. Okay? So unchecked exceptions, again, are runtime exceptions and these errors. Now, we can declare, throw, and catch exceptions. Now, this is a good example because what's happening is that we have a method 1, we have a try block, and in it we're invoking a second method. Notice it has its own, this thing has a catch block. So when you invoke this method 2, you're going to go into the method 2, and the method 2 essentially is saying that I'm going to throw or declare an exception. If an error occurs, I'm going to throw the new exception. Again, we'll see examples of these, but what's important here is the difference between the word throws with the S and the word throw. Throws exception, meaning it means essentially that this method is going to declare or deal with a particular type of exception. Throw new exception essentially tells it to do it. So this is, we're actually creating a new object from the exception class. Okay, so again, we'll talk about these a little bit more detail through a couple of examples. So this is really not important. Throwing exceptions example with set radius. I have an example of this that we'll look at. Notice this is public void set radius that accepts a parameter double. And we're telling, notice this is in the header of the method where we say we're throwing or defining an illegal argument exception. So again, this is just a definition. Now we're saying if new radius is bigger than 0, assign radius to new radius, but otherwise we're going to throw a new object of the illegal argument exception class, and we're passing to this constructor essentially a message. So notice with this example, what happens is if you create an object and try to set the radius with a negative value, it's going to actually throw the exception, meaning that you're saying whoever called this function, the program that called this function, or the method that called this method is going to essentially deal with that. Or essentially, to propagate or maybe do something else to it. So just with that, let me go in here. I'm going to go ahead and close all of these so they won't confuse us. And then we go back to here on here. I'm going to open up this circle with exception.java and test circle with exception.java. So I'm just going to drop these into TextPad. So essentially, this is the circle class. We're doing public class circle. Notice you have a radius, and we have a static integer number of objects. Remember, static variables keep their values as you create objects from this class. So notice right here, we're saying set the radius in our constructor. And notice that the radius is telling us that we're defining this illegal exception, and we're also telling it what to do. So now when I go back in here, this statement right here creates a circle exception with C1, and it's going to call it with a radius of 5. So radius of 5 has no problem. So the radius sets for that circle is 5 now. But right here, we're going to catch we're going to essentially run into the error. So what happens is that this statement is going to cause this exception to be thrown, and then we're going to actually go to its catch block and essentially tell it to display the value of the object. So this is what comes essentially what is displayed by Java for you. And notice again, the program doesn't crash. It will just come back in here and continues. And of course, I'm saying how many objects did I actually create. So notice if I run this program, this one is not going to cause a problem, but this one will cause a problem. So notice it says java.lang.illegal argument exception. Radius cannot be negative. That was my error. And then number of objects created was 1 because that was it, right? Because we never created this object because of the exception. So so that's an example that you should probably again take a look at a little bit more closely when you're done viewing this demo. The other thing I want to show you was there is a program called Catching Exception Demo.java. So let's see if we go in here. Your book kind of explained this, or actually talks about this, and I put it in here so you could kind of see what's going on when you have methods that are run within try blocks, and what happens as these errors are propagated. So when I run this program, if I say method 1, of course I'm going to say call method 1. So I'm going to come in here to method 1, and I'm going to print in method 1. Then I'm going to try and just divide by 0. Well, this is going to catch, or this is going to cause an error. So this statement isn't going to get executed. Instead, I'm going to go here and see if I have an exception that I'm handling. Notice I've essentially commented out arithmetic exception. So this error is not going to happen because it's not an index out of bounds exception. Division by 0 is an arithmetic exception. So I'm going to go ahead and uncomment it. Again, your task would be to essentially turn these on and off just to see what happens. So when I divide by 0, it's going to actually go ahead and handle it. Gives me the processing of E2, then it's going to go to statement 4, but then it's going to get out, right, of the method 1, and then you're thinking, well, it might go to statement 1, or it's going to go, to arithmetic exception here and process this statement. So what you should do is essentially compile this code and run through it and make sure you understand how these things are propagated. So method 1, that was the first one. It caused an error, so it went here to process E2 because it caused the error. So I'll go back in here and bring this up. Then it says statement 4 because we caught it, and the program executes, goes on to statement number 4. Then it's going to come back all the way up here and it's going to execute statement 1, which is, again, that's okay. And then of course, there is no exception. We already handled it, so this is not going to go here, and instead it's going to print statement 2 and then the end of main program. So what you should do as an exercise is, go ahead here and essentially, by the way, essentially comment one of these and uncomment one of these. Exception is the parent of all exceptions. So if you're not sure what type of exception it is, you can always use exception as the superclass of all exceptions. And again, your book explains this concept also. So let's go ahead and come back to our examples. So again, this is how exception handling works. The statement that you think is going to cause an error will be tried in a try block. And then we could have a series of catch blocks. So for the exception 1, we handle it for exception 1. This could be an arithmetic exception. This could be an index out of bounds exception. This could be an illegal format exception or illegal number of argument exception. So you can catch all of the various exceptions that you think could happen with your code, and then handle it appropriately. Okay, so this is a good example in your book, and you should actually go through this with the example that I provided on catching exception demo.java file that I just showed you. Okay, I'm going to go ahead and test circle with exceptions. I think I just went over that. Rethrowing exceptions, we're going to skip this concept, even though it's really all it means is that you can actually throw the exception again, or essentially force Java to terminate essentially the program if it has to. Finally clause is kind of nice. This is used for essentially bookkeeping, or if you want to clean things up. Finally clause is always executed regardless of whether we catch an exception or not. So these slides are kind of nice because they kind of walk you through these statements. So make sure you go through these animations on your own in the slides that I've given you. Now, cautions when using exceptions. Don't overuse them because they will take resources. When to throw an exception? Essentially, again, you throw an exception when there's something that you know you would want to handle and deal with. So, essentially, you would want to avoid using exceptions, and that's why really what this chapter I wanted to do is just cover the basics of exceptions. So instead of doing a try and catch, well, why not just using if statement, which is what I showed you with the division by 0 example that we had. Defining custom exceptions, you can actually create your own exception classes, even though Java gives you tons of exception classes. And this is another topic that you won't be responsible for in this course. But if you want, just read up on it. Again, it's just creating new classes that inherit from the exception class, and then you can add your own functionality to these custom exception classes. But again, we're skipping them. Assertions, these come from the companion website, and these are also excluded from this chapter, so you shouldn't worry about these. So the next thing I want to talk about is the file class. Now, of course, up to now, we've always read data from the keyboard and then written data to the screen. So it is possible to read and write data to and from files. And of course, as you might have guessed, we use a class called the file class. Now, the file class actually gives you properties or information about your files. For input, we're going to use the scanner class. And for output to files, we're going to use a class called PrintWriter. But I'm going to explain that also. So again, your book gives you the file class with all of its methods, which is pretty nice. And of course, if I go in here, let's just go quickly. I think I have a file called test file class, and it's right here. So I'm just gonna double click it to open it with TextPad. Notice I have file. Again, this is of course you all know already how to create objects from classes, right? So I'll create an object called file and new file, and this is the absolute path to the file. Now I can use all the methods for the file object, whether it exists, it gives me the length of the file, whether I can read from it, I can write to it, and a whole bunch of other things. So if I ran this, it's just going to give you information about that file. Of course, C:/test file class.java doesn't exist on my system, so it doesn't exist. But if you gave it a file that did exist, then it will give you information about that file. So make sure you execute this with various files. Now, if you don't specify the path, then this becomes a relative path, and all it's going to do is going to look at the current directory where you're running the code for the file name. You can also use C://, which is how we use it in in DOS world. But if you do want to use backslash, you have to use 2 instead of 1, because escape character such as /t will be treated as tab, and that's not good, and Java will give you an error messages. So it's basically probably best to just use a / to essentially provide absolute paths to files. Okay, so that's how you check for files. And then when you want to write to a file, we use the PrintWriter class, and if you want to read from a file, we use the Scanner class. So notice PrintWriter class has a whole bunch of methods. Notice it has print, and print ln also is available, and so you could use print to write data, and then we could use to read data, we use the Scanner class to read data from a file. So I'm just going to go ahead and open up both of these files. So I have readdata.java and there is writedata.java. Of course, these are just examples so that you can see the operation of these files. So if we go ahead and go to our programs, let's see, come on. Well, read data, write data. I thought I grabbed it right there, and right there. Okay, so write data. Notice I'm opening a file. I'm checking to see if it exists. If it does, I say it already exists. And system.exit, by the way, exits the whole program. So if the file is scores.txt, which is in this current directory, in this directory right there, if it already exists, I get this error message. If not, I'm going to create a PrintWriter object, name, say output. Again, this could be any name you want, so is this. But these classes, you need to have those. So you say new PrintWriter with the file. Now notice PrintWriter doesn't accept a string for the name of the file. It accepts a file object. So that's why you have to first create the object and then pass it to PrintWriter. And notice all I'm going to print is these things to it. So right now, if I run this thing, it says, hey, file already exists. So it looks like I have a file called scores.txt. If I change this to 1 scores.txt, I know it doesn't exist. So it didn't give me an error message. It says press any key because I'm done with the code. By the way, this output.close is very important to have. So if I go back to my folder right here, notice 1 scores.txt is created, and it's full of the data that I just wrote to. If I go to my other program, read data, notice again, same idea. Again, you can create as many file objects as you want. If you want to write or read from multiple files, you can. And notice because I'm going to read from a file, I put it in a try statement, because that way if there are any exceptions like file not found exception, I can handle it. But remember, we just said that instead of try and catch, we could actually check, if the file exists, we want to do all of this. Otherwise, we want to give an error message. But I just showed you that you could that you could also do this. The way you read from a file is you use this method called hasNext. The nice thing about has next is that it looks at the file, and so long as there's data to be read, it will actually, this method will return true if there is data. So it looks like I'm reading data from a file called scores.txt. And notice I'm using the relative path, so it's going to be the same place. And the first line is John T. Smith with 90. So let's go back to our program. And so obviously John T. Smith is going to have a value. So first name is going to be input.next. Remember, input.next only reads up to the first white space. So it looks like I'm going to just read John. Middle initial would be the next one. And then last name would be the next one. And then score would be integer.parseInt. We talked about this in a previous chapter. I could have just used input.nextInt to read the data, to read the numerical value, and then display the value maybe what looks like I'm multiplying the score by 1.2. So if I run this code, there is no user interaction. All the data actually comes from the file. So notice 108 and 102 are those scores multiplied by 1.2, or it's actually like 20% increase in the test scores. Looks like it. Okay, so essentially we use this while loop because with files, when we're reading from a file, we obviously have no idea how big the file is. Now sometimes we could actually read the file, find the number of records in it, and then essentially write the data into an array and process the file again. Remember, if you want to read data from this file again, you have to make sure to close the file before you can read or open it again. So essentially that's all there is. And again, for file operations, we're just going to deal with text, simple text data files. We're not going to deal about deal with binary files. Even though you could, but it's not covered in this class. Okay, so this stuff about reading data from the web, your book gives you some examples that you could look at, but again, we're not going to cover it in this class. And looks like that's it. So what we covered in this chapter, then remember, is basic concepts of exceptions. Again, the word exception simply means error. And exceptions, though, the only difference is exceptions are errors that can be handled by our programs. Of course, errors are things that can't be handled. So if I run out of memory in my program, then I really can't do anything. Or if Windows runs out of memory, we can't really deal with that kind of data. But any kind of logical errors, we should be able to deal with exceptions. And we also talked about basic file operation, using the file class properties and methods. And we also talked about how to read and write to and from files. Okay, I hope this was helpful. Have a good day or good night, depending on when you're viewing this. Goodbye.